Okay, so in this video, I'm going to talk about the tool that we're going to be using. It's called TheBench. Essentially, it's a tool for writing categorical grammars and uh, write grammars. You can train grammars on natural language data, of course, um, and compare grammars. And that's roughly what's called what I've been calling categorical typology, which is essentially comparison of grammars through their categories. And of course, category here is understood in the categorical grammar sense. Um, Category is essentially a pairing of syntactic command and semantic command for every element of grammar, including the verb, which gives you predicate argument structure, but also like noun phrases, like the distributional category of the noun phrase and the meaning of the noun phrase and stuff like this. Okay. Um, and of course, in writing a grammar and comparing the grammar, you don't need parameters. But here, for training the grammar and comparing them, we need the notion of parameter. Um, so this notion of parameter is essentially coming from science, so it's quite unlike the ones used in psychology. Parameter in science is essentially a set of values, maybe I should say parameters, set of values to identify a data point. Okay. Data point in our case is a possible grammar. Okay. Here we are counting or we're relying rather on a very influential hypothesis coming from psycholinguistics. It's called continuity hypothesis by Stephen Crane, which basically says there is continuity from child grammars to adult grammars. There will be no quantum leaps. There will be no sudden switch to another way of thinking about grammars. It will be continuous from very first child grammar to very last adult grammar. Okay, which means if you think about this continuity hypothesis, how are you going to test it out, and how are you going to identify the possible number of possible transitions from one grammar to another? Well, you need to identify a grammar by the choice of its data points. So it's just to give you an example, in our case, in the case of grammars, for instance, let's just take a grammar with just two elements. Let's say hits, which is a transitive verb in English with this semantics and syntax. And let's just say arrives, just two elements, which is intransitive. Therefore, take one argument. Okay. So because it's got two elements, you can identify if this is a grammar, if this is the whole grammar. You're basically saying, well, if this is element number one, this is number two, so there will be number one, number two, and these will be located. Let's say number one is here, value, bar value, and bar value here. This will be your G. Okay. Um, um, so essentially, this means like this has a value. Uh, okay. So let's say a three-dimensional uh, uh, grammar. So this, let's say G2 will be like hits lambda x, lambda y, hit xy, arrives, lambda x, arrive x, and then like Mary, noun phrase, Mary prime. So it's got three dimensions, and essentially it's going to be represented like this: 1, 2, 3, 1, 2, 3. If you have value for like let's say 0, 1, 1, 2, 3, 2, 4, 6, 3, 6, 7. I mean, they can be in different dimensions. So let's say the parameter of this let's say like this is 2. Let's say arrives is like arrives will be like 3, and this will be 6. So if this is number one, this is 2. Second one is 3. So this, and the third one will be 6. So it's in this plane, and your G2 will be positioned here. Okay. So G2 is in a three-dimensional space. G1 was in two-dimensional space. In other words, number of parameters is in a grammar is number of elements of grammar. That's why you can say, well, you're just identifying data points in the grammar. Okay. So once we do that, we can train the grammar. So this is what we're trying to get at. We have a theory of grammar. And from this, we want to get to possible grammars. And using natural language data, I want to get to models of grammar. And either self-supervision or otherwise, and parameters, I get a model selection and development. Of course, when you develop and then you choose. And that's going to give you a preferred preferred in the sense that the data biases in such a way that data makes this grammar most likely. Okay, among the possible alternatives. So in modeling, if you don't have a theory space to constrain possible grammars, then essentially anything goes, and that's not going to give you a lot of convergence in a model. But if you have a theory of grammar that says, well, that's a possible grammar and that is not, then you can move on to say, well, if that's the narrow space of possible grammars, then I can expose that narrow space to natural language data to favor certain kinds of grammars, models of grammars, again being exposing it to self supervision, like what does the the child learn being exposed to a certain kind of expression? What does she infer that expression to mean? That kind of form meaning pairs. If you so this is like form without biasing the child toward any kind of syntax. We just say this form has this meaning, that form has that meaning. What kind of models and what possible models in the modeling space of grammars are made most likely by this expression and what the child is assumed to understand from that expression. Okay, that's the essence of modeling. So what I'm going to do now um, is I'm going to show you how some of that is done in the bench, so that when you see parameters like these in the data, you wouldn't be surprised about where they're coming from. So I'm going to share my uh, screen. Okay. Um, so I'm using the bench. I'm in this directory. This is the course directory. If you look at the course directory, you're going to see a project one. This is going to be your project that you'll be working on in next week. If you look at the contents of that um, uh, 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 folder, you're going to see a grammar. For instance, let me show you English grammar that I showed that I wrote up as a toy grammar. In this grammar, you see like things like knows, uh, as the English know, which is essentially like I know the book kind of know, and the second know here is um, uh, uh, the distractor. Why is that called a distractor? Because the first no means no, but the second no is assumed to mean hit. And essentially, that's like modeling the potential misunderstanding by the child. This was a point that was made by Quine many years ago for other kinds of reference, like are you referring to the whole? Are you referring to parts of things? Like that's called the Gaba experiment. The second no is the epistemological no, like I know that you like me and kind of thing. Why? Because it takes S as an argument rather than a noun phrase. And again, it has a distractor rather than no. It might mean C. Um, so this is a possible grammar with a possible potential misunderstanding of the child built into it, so that you can see whether the child uh, the data that the child is exposed to is going to favor one of these and disfavor the others. So And this data is called the supervision file. So this is assumed to be what the child is exposed to. I named it like English supervision, and I am in this experiment like if the child is exposed to this, if the child says knows that John loves Mary means John loves Mary. This is the expression itself. This is the predicate argument structure that is assumed to be inferred by the child. And if these are the things that the child is exposed to, what kind of parameter change is going to happen in my grammar so that this data is most likely? Okay. And as you can see, there are some fairly close, fairly complicated structures. Mary knows John loves Mary means the main predicate is no, and Mary's knowing is essentially John loving Mary. But if you look at the supervision, this is actually self-supervision because there is no assumption about morphological structure or syntactic structure of what connects the expression on the left to the semantics on the right. This is all like, this is what the child hears. This is what they think is inferred by a child if she gets it right. So what do you do with this? Let me show you the bench first. um, the tool. So this is how you call the bench. And it says it's a tool written in two languages, Python and Lisp. It gives you data and it gives you your current working directory. um, and if there is a help function, if you just use question, here is the help function, and this is sort of very old style non-graphical interface to command structure of the bench, just to give you uh, 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 how the thing works. So all commands are essentially one letter commands, either a letter or like a symbol here. If it's a letter command, it's about the processor, analysis, training, stuff like this. If it's a symbol command, it's about information. So it's like a and dot means dot star means many arguments separated by um, um, uh, by space. So G something means load the grammar named by G. So if you like GEN dot grammar, which is the name of my grammar file, it's going to say, I checked your grammar. There are no uh, errors in it. So now we can analyze. Let me show you what was in the grammar. So O is the operating system command. You can call operating like show me the directory, show me the contents of the file. You can do things like this. So let's do some analysis. So there is John and Mary in uppercase, in surface structure, in the meaning they're just lowercase. So you can essentially say, analyze John knows the book. And it's going to say, it's done the analysis. There are two analyses. If you want to see the analysis, just use the comma command, meaning show me the analysis. If it's going to show you two analyses, one says John is a noun phrase here, knows is a transitive verb, and you get John knowing book. There's another analysis, and we can talk about in class why there are two analyses here. But the whole point is since there are multiple analyses, you have to have a training to build an understanding of which one is the preferable one. So it's going to give you all possible analysis if there is no training in your grammar. Um, um, if you want to train your grammar, you can use, um, let me show you again, um, uh, the T command. T says dot 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 means trains grammar in file, the first dot. So this is that I'm referring to dots in sequence. The first dot is the grammar file. The second dot is the training data. And what are the training parameters? Well, it's the third dot here. Okay. Now you can keep typing these from a command line, or you can put them in like macro files and say run these commands offline. So like you can do at a set of commands and just save the log somewhere. So let me show you one such file called, I used TBC extension to mean the bench command. So if you look at this file, there are a bunch of commands. The pass command just means just show me what you're doing. It's like a comment file. T command is the bench command, says take the EN grammar, train it on supervision data in this file, and look at and the training parameters are essentially these experiments. So if you look at the experiments, um, I've shown you the grammar file. I've shown you the supervision file. Let me show you the experiment file. This is essentially like every line is one experiment. It says these are all technical aspects, like these are training parameters, and it says, well, save it in this file and call this function. I'm going to talk about these. These are more of like a detail. I'm going to talk about this in class as you begin to do the project. So call this file, and you get results. So like 1, 2, 3 experiments. Why 3 experiments? Because one, I want to change the training parameters so that see how to best fit the grammar to explain the data without, of course, overfitting the data. Um, um, so you're going to learn a whole lot of experiments and then choose among them to be the most likely grammar to explain the grammar that makes your data most likely um, coming from supervision. Okay. Um, I save these commands in this macro files, entbc. What I can do is run this add command, and I say, well, just do the instructions here, and I am doing this experiment to see whether English is SVO and OS, because that's how uh, uh, my supervision data is factored out. You can see it in the file, and I'm going to talk about this in class. Save this in this log so that I can see what's happening. It's going to run the experiment. Um, and it saved the log of what it's doing in this SVO obvious file called log.log. I guess you don't need the log extension. If you look at that file, it's going to explain what it's doing in every experiment. Experiment 1 is going to do this. Experiment 2 is going to do this because that's what I defined in the experiment file. Experiment 3 is going to do this. And then you go out, check these results of these experiments. Essentially, every experiment gives you retraining, readjusting the parameters. So that's what it's going to do. So let me just, and I've done this before, and I saved it in a file, so, and I kept it. So if you feel like checking it out yourself, just go to results file dossier and just look at, um, uh, for instance, one training. Let's say Let's look at the SVO supervision data. These are names that I've given myself, but I've completely forgotten what I meant by them. If you look at that file, it's going to say, well, this is what you tried in this experiment. These are the rules that you're going to be using, and there are some missing grammar entries, and this is the training that you're going to get. For instance, initial value of certain kind of node was 1. You just initialize certain value. It goes up to 2.9 because of what you put in the supervision data. The second one, remember, the distractor becomes minus because it's less likely to be explained by your grammar. So you can see that there are initial values of parameters, and after the training, the parameters have been adjusted. Okay, and then from these you make a model selection, and I'm going to talk about that in class um, um, uh, in the week just before spring break. So it's gonna be like 2 weeks from now. And so that, I mean, this is the kind of stuff you need to do, um, in class to understand what's going on. So I'm going to do that next week. All right. So this is the idea, um, and I'm going to show you how to do that in the project after the midterm. All right. So take good care of yourselves and see you soon.